But for now, I am utmost glad to welcome on stage Dr. Luc Julia for a fireside chat on AI in space. Between hype and operational reality, time to break the myth. Welcome. Hello. We are glad to have you here. Good morning. Well, I imagine everyone in the room knows who you are, but as we never know, I will just mention that you have first had a degree in mathematics, a PhD in computer science at the École nationale supérieure des télécommunications de Paris. You hold a dozen of patents. You are also a bestseller, more than a dozen. 36. Yeah, 3 times. You're a bestseller author, The AI Illusion. You were a pioneer in AI and the Internet of Things. You developed the first LLM-based avatar in consumer cars. You directed Siri at Apple. You're the co-founder of many startups at the Silicon Valley. I will stop counting there. You created also nuanced communication, a leader in speech recognition. Chief Technologist at Hewlett-Packard, CTO, Vice President of Innovation at Samsung Electronics, and one thing people may not know about is the RT series that you were feature in, Silicon fucking Valley. I must say, I adored the show. So we are glad to have you here, and the aim is perhaps first to do a bit of an AI reality check. And the first question, because, well, we are in front of cybersecurity people from the space industry too. I have one question for you and maybe one for them too. You often say that there is no such thing as artificial intelligence. What do you think people in the space industry misunderstand the most about AI?
The I.
The I.
Yeah. The issue is that, you know, when we talk about AI, we focus on the I. Focus on intelligence. We believe that this thing, that is AI, is going to be as or more intelligent than we are. First of all, I don't know what that means. And you know, intelligence is very relative, right? So, really, I don't know what it means, especially when we are talking about AGI, artificial general intelligence, that is supposed to be the aim, the goal that we have, you know, in AI. So that is ridiculous to try to copy us, basically, or to do a better version of us with AI. I think that this is our quest, the human quest of creating God. This is really what it is at the end of the day. So this is why we need to, you know, breathe a little bit and do a little bit of yoga or something in order to realize what is AI and what it's not. It's not intelligent. It's kind of stupid, actually. So this is what we need to realize. So AI is just mathematics, first of all. So it's not magic. It's not what I call the Hollywood AI. Hollywood AI is what you are going to see in the movies, you know, like Terminator, right? It's going to be dangerous. It's going to kill us, to replace us, to whatever. Okay, so it's Hollywood. Or it's going to be like in the movie Her. You are going to fall in love, you know, with the AI. I don't recommend it. I mean, it's not going to go anywhere. So this is not it. I mean, the reality is that AI, if I really have to give a definition, you know, as a singular, is a toolbox. A toolbox where there are tools. And tools that are as efficient as a hammer or a screwdriver or a saw, and that are very, very good at what they are supposed to do, but that they are very potentially dangerous at what they are not supposed to do. So if we consider that AIs are those bunch of tools, then, you know, we start to understand that at the end of the day, like a good hammer, we have the handle in our hands. We decide to do whatever we want with them. We can decide to throw the hammer. It's possible. It's stupid because it can do a lot of damage. But I can decide to use it correctly, you know, by driving the nail in the wall. So that's our responsibility. AI is not magic. AI doesn't do anything by itself. Okay? So AI is our responsibility, and it's just a tool that we have the control of if we want to.
We will talk later on about this control and how to frame it, frame the users. But you mentioned that the important thing about AI is what we do about it and what we do with it. Where do you think machine learning actually is useful in space systems today, and what would definitely not be ready for those kind of mission-critical environments?
Yeah, so I'm not a specialist, of everything that is up there.
Not too.
but the reality is that I believe when I look at any domain, that there are fields of applications. After a while, when you are looking at whatever domain you are looking at, you find use cases. So, I mean, if we want to compare a domain that I know a little bit more, the automotive domain with the satellites domain, I believe that in the vehicles, there are a lot of things that we can do with AI. I mean, about maintenance, about knowing when some pieces are going to fail and stuff like that. So just in terms of knowledge of the system itself, I mean, I'm sure there are some very interesting things. And then there are everything that is on the side, right? I mean, knowing where it's going. I mean, all the things that you can imagine to want to control or to have a better control about the environment of those vehicles. So many opportunities, I'm sure. Again, I don't know exactly what, but I mean, when I see, especially with the Gen AI, the latest generation, that came up 4 years ago now. So Gen AI, you take a while to understand what it is, but once you understand what it is, you can find a lot of use cases. I mean, you know most likely this study from MIT that was released in August 2025 that showed that 95% of the POCs didn't give anything, in terms of ROI, because it's still new, it's still something, it's still innovation. We're still looking what it is that we can do with those things. But when you have 95% of failure, it means that you have 5% of something that works. But with the amount of POCs, I mean, there were millions of POCs, that were done. So it means that there were some use cases that were found and that are becoming more and more to be applicable and that are releasing, some interesting results.
Yeah, you talked about your experience in automotive. What lessons would be transferable, and when it comes to risk, what do you think would be an acceptable level of risk?
So first of all, I mean, the reality in an automobile, like I guess it is in a satellite, is that you need to be as independent as possible. You cannot rely on what is outside, just in case, the outside is not accessible anymore. In the case of the car, the outside is going to be the internet. So you need to have the system that is going to continue to work even though you are not connected to the internet. A lot, I mean, for the past 20 years, we have been relying a lot on the internet. Everything is coming from upstairs and it's great. I mean, we are going to save the world with the internet. The reality is that when we are not connected anymore, you are naked. And, you can't be naked especially when it's about security. So in the car, you need to have systems that are going to be resilient, that are going to be local and resilient. So that's something that is very interesting that we are seeing now, in terms of LLMs, for instance, those new AIs that are becoming more and more SLMs, small language model, that we can now, download and have, downstairs, in order to have something that is smaller, more specialized, but that is going to be resilient and working locally without any dependency on a potential, connectivity. So that's something that is very, very interesting. You have to have, at minima, a degraded system that is going to be local. Yes, for the full feature and all the bells and whistles, you can imagine to have something that is connected and you are going to have all the things coming from the internet and so on. It's going to give you the menus of all the restaurants around you and so on. Great, but I mean, in order for the car to brake correctly, I mean, you need to have it locally. So that's the main lesson is that And even though when, especially in the car, when you start to have those systems that are going to be more, using those LLMs that are more dialogue kind of systems where you have, you need to have the driver or the passengers that are going to feel comfortable and to feel that they are loved by the car, in the car. I mean, this dialogue, you cannot just cut it if you don't have internet anymore. So this degraded system that I was talking about needs to have to work a minimum like if it were still there, even though it's not totally there. So that's also something that is very important in terms of UI, in terms of interface. In terms of security, of course, I mean, the more local it is, the less connected it is, the better it is.
Okay, just to mention to the audience that if you have questions, you can raise them on ConnectMe, the application we've been using so far, and I will read them aloud. So do not hesitate to do so. You helped shape voice interfaces that millions of people use daily. I wonder, with what you just said about making the user, the passenger, feel like someone is there, that they're being taken care of, that they are being loved. How do you imagine human-machine interaction? Not only in cars, but also for mission operators and satellites, because we know that those lessons can be taken on other fields.
I mean, for people like me, who has been working for 40 years on UI and on human-computer interaction and human-machine interaction, the ultimate relationship between those machines and the humans is the machines that are going to be able to understand every single human signal, right? Not only voice. Voice is great because it delivers a lot of information. It has a lot of significance, with a very efficient way. But also gestures, feelings, maybe your temperature. I mean, some other cues that you have in your body that are going to be interesting to analyze in order to make the system understanding the context of the dialogue, right? So the ultimate UI, the ultimate human-computer interface would be something that is multimodal. So back, in the end of the 80s, my PhD thesis was called multimodal interfaces. So that's exactly what the aim. Now, where we are today, it's much better than where we were with Siri, 15 years ago, or with of course, the speech recognition that we had even before. So we are progressing. Today, the dialogues that we have with Whisper, for instance, and those the LLMs, it's pretty good in terms of dialogue. So Siri, for instance, it was only a one-shot thing. You ask a question, it gives you an answer. Okay, good. And now you can continue, but it's going to be very single-purpose things. Now with Whisper and the LLMs in general, you are going to have a real dialogue. You can refine the question. You can, go deeper, and you have the feeling, and this is just a feeling, that it's a person that you are talking to. So it's becoming more and more anthropomorphic, which is the goal of the interface, to make you comfortable to talk to this thing, to make you comfortable in order to have this dialogue. So it's great to have that, but at the same time, you need to understand that it's still a machine. So you need to be sure that you're not going to trust too much the thing, if it's not going to, it might not deliver exactly what you want to deliver. So, but anyway, so now it's better in terms of speech. In terms of natural language, so the understanding of the context and the thing, there's still a lot of work to do. Sometimes those AIs today, they are putting you in a path that is not the exact path you had in mind, and it's because it doesn't really understand the meanings. It got the words, but you have several contexts that are possible. So this is something that we need to refine. And as I said, after that you add the other signals like gesture and the other things that I was talking about, so the multimodality.
We had one speaker yesterday, I think it was Marcel Taubert, who said that the attacks usually come from from the trust we misplace. I will say it again. The attacks come from the trust we misplace. And we were talking about AI risks. And with what you just said, isn't the highest risk that of dependency?
The dependency is a risk, and the trust is a risk again. I mean, because the issue with AI, and especially when you're talking about those LLMs and those AIs that look to be human, right, or look to be something that you can trust because it's going to have the same language that you have. You know, those systems like, you know, in the Hollywood movies where you are talking to HAL, you know, and, you know, you have a flow that is very natural, and so you believe that HAL is great, right? I mean, he's right. I mean, this is where it's an issue because HAL is a machine and it can be hacked. Okay, you can be hacked too somehow, but the machine can be hacked, and so it means that if you put too much trust in this thing that looks like you need to be careful. In a human, because of the other signal, you know, that I'm talking about, you can detect sometimes, you know, that okay, this is weird. There is something weird with a machine that has only today, you know, voice. I mean, maybe that you miss something. And you believe in this machine where you shouldn't believe it.
And maybe to go further on that, where do you think human authority should remain non-negotiable?
I mean, it's not negotiable is what you put in the machine yourself. So now, you know, we come back to the origin of the machine, you know, and the program, whatever it is, and you can call it a black box or not a black box. I mean, we can discuss, you know, what it means, but whatever you put in the program, being the logic, being the data, being the algorithms, you need to trust them and you need to decide that. So the non-negotiable part is the origin of the system. You need to control what you put in the system. If you say, and I hear sometimes, you know, yeah, it's great because the machines are going to build machines. Be careful. I mean, don't let, you know, random do stuff, because by definition you don't know what it's going to do. So be sure that you are always somehow, you know, you are the one having your hand on the handle of the hammer, always. So this is not negotiable. They are just machines. We are the humans. We are responsible at the end. At the end, this is our responsibility. We are the ones, whatever system we are talking about, we are the one pushing the button. You know, wherever the button is in the string of command, there is a human somewhere pushing the button. And so that is our responsibility.
Yes, and I imagine that when the hammer eventually falls, it's on someone else's hand. We've been talking yesterday a lot about reputation issues when it comes to reporting failures or shortcomings, problems. When it comes to AI, this responsibility is sometimes blurred.
Yeah, I mean, as we said, since we can make a lot of trust, we can give a lot of trust, you know, into those AIs. I mean, the responsibility is blurred, as you said. So that's bad. So this is why we need to redefine, and by, you know, regulation or whatever it is, we need to be sure that we understand exactly in the string of commands who are the responsible people. We cannot say at any point, you know, the responsible is AI. Doesn't mean anything. AI doesn't think. AI doesn't create. AI doesn't innovate. Okay, we do. So we cannot say the AI is responsible. When I hear something, the debate, you know, in the car industry, for instance, you know, about autonomous cars, who is responsible? The car is responsible. What does that mean? The car is responsible for nothing. Is it the builder of the car? Is it the guy who did buy the car? I mean, there are a lot of things that you can imagine. And it depends. So this is where, you know, you have the jurisprudence and you have some, you know, laws and expectations that are going to come up, and we are going to find out. We are going, as a society, to decide where the responsibility lies, you know, but I cannot say it a priori.
Well, in AI, there are rule makers and there are rule takers. I wondered, given your expert position, are you maybe involved in, well, as a consultant on regulating initiatives in Europe, or are you satisfied with the current state of things?
Unfortunately, I think that Europe, in particular, you know, is not asking a lot of the experts about their law. Specifically, the AI Act is an aberration, a total aberration. I mean, it's just unbelievable. It was in reaction of the release of the LLMs of the Gen AI back in 2022. And now it's applicable since August 2024, 2025. So that's bad, because basically you in Europe, you did some incredible regulations that are totally, unapplicable. And this is when you talk to the people, and when you talk to people, to the CNIL, for instance, in France. I mean, I had a debate with one of the guys of the CNIL, a few months ago, and he said, "Yeah, we are still trying to understand how we're going to apply it, because it's actually, against some other laws or regulations coming from the European Commission as well, the Europe as well, like GDPR. So they are going against each other. So I mean, that's going to be very difficult to apply. I mean, I'm for a much more pragmatic approach, in terms of regulation. And as I said before, I mean, I'm for the posteriori approach, like we do in the States. For instance, is that, yes, we are going to make mistakes, we are going to have issues, we are going to have, maybe death, but at least we understood the problem, and we fixed that very problem that we just understood. We don't try to anticipate something that we don't understand. And unfortunately, in the AI Act, for instance, we put a lot of things in it that we don't even know if it's going to happen. And the issue with this particular thing is that potentially it cuts a lot of innovation that could be done, which is not the case, of course, in China and the US.
We have questions from the audience. Thank you very much. A question from Constant Blanc. What were the main barriers to deploy and use AI in cars? Do you think they are currently the same for the new space?
So, I mean, we do deploy a lot of AI in the cars today. I mean, for instance, I'm not going to do some publicity here, but when you look at the latest cars that we worked on, that I worked on, at Renault, the R5 and the Renault 4, there is a bunch of AI in it. So, I mean, again, when you think about an industry, you have to think about the object itself that the industry is releasing, but you have to think also about the way the industry is going to release this object. So, and it's most likely the same thing in your domain, that there is a lot of AI already, the old AI, the one that is more than 4-year-old, a lot of old AI in the factories, right? With robots and stuff, automation. I mean, there is a lot of AI there, a lot of predictive maintenance and stuff like that. So in order to know if the robots are going to be in good shape, blah, blah, blah. So that, for a long time, we are doing for almost 40 years, we are doing a lot of AI in those parts. There is more and more AI now in the white-collar population in those companies. So what is it? It's going to be specifically with LLMs in this case, so the new AIs, are going to be very well used in everything that is going to be document generation and all that. So it's going to help a lot this industry as well. So this is, let's say, the side, but that is very important because this is not the object itself, but this is what leads to the object. And then there is the object itself. And the object itself has more and more AI. So, I mean, your cars, whatever they are, and it didn't wait for the LLMs neither. They are more and more autonomous. I put the quotes because what we call the systems that are the systems that are going to help you to navigate, they are pretty good not navigating the streets, but to brake better than you, to see better than you, to do all that. So all those systems, they exist for a while now, and they are just better than you. This is the definition of a tool, right? Yeah. It's better than you. So we have a lot of those systems in the car. And those systems, more and more, we rely on them, and this is why they cannot fail. Let's come back to what we were talking about before. But the LLMs in the car, they are also there in order to be used for more the interactivity with the car itself, to understand the car, for the car to understand me, to have a dialogue with the car. So in the latest R5, for instance, there is a little avatar that is there that you can talk to like you were talking to the car itself, and that is the representation of the car. So there is AI in those cars for a while now. And I imagine for the new space, for the space domain, it's the same thing. You can, as I said earlier, you can imagine a lot of use cases that are going to be applying AI.
And that echoes a question from Jessica Smith. Thank you, Jessica. Space systems already use formal verification and fault-tolerant architectures for classical software. Do LLMs just slot into those existing frameworks, or do neural networks require fundamentally new assurance methods?
It's much more difficult because the systems before, they were based basically on logic, right? So it means that you, in order to do the verification, you were doing some formal verification by following the logic of the system themselves. So it was, I wouldn't say easy, but it was possible to find the path, in order to find potentially the faults that were there. Now what we are talking about when we are talking about LLMs and about those new AIs, I'm going to say new AIs for machine learning, deep learning, and Gen AI, that is the past 40 years, basically. The issue with that is that it's statistical models. So in statistics, as we all know, without even doing statistics, is that 100% doesn't exist. So we have to define what is our own threshold that we are ready to accept, right? So this acceptance, this is a human thing. The reality is that we are not ready to accept the failure of a machine like we are ready to accept the failure of a human. But the thing is that you need to, now, we need collectively at one point, and this is where regulation can help too, we need to accept that we fail as well. And an expert, for instance, and it's difficult, it depends on the domain, it depends on other things, but if you take a medical expert, or if you take any kind of expert, he or she fails. And we consider that 5% failure is pretty good. So those guys are pretty good. But when I hear, and when you hear, when you put yourself, in those systems, you say, I need to be, 9.9999999. Good luck. This is just not possible. So relax a little bit, because in any case, you are not going to be able to achieve those things. Because even though if you say that you do, you actually don't. I'm sorry. So we need to reframe a little bit this idea of what is the real tolerance. And in that case, after that, we will be able to use the statistical system to look at the statistics to generate, the acceptable risks for those LLMs and for those systems in general.
The room woke up. Thank you very much. We have a lot of questions and a little time, so I apologize for for picking up questions. I know that there will be disappointed people, but I think discussions can go on afterwards. One question from Colonel Ludovic Monera. I will display it, and it echoes another question. Having a human in the loop is a clear expectation in the West, especially within the armed forces, for the use of AI on the battlefield. But what can we do if some other parts of the world decide to go full autonomous combat robots?
So first of all, full autonomous combat robots, I don't know what it means, right? Full autonomous combat robots or full autonomous whatever means that I just release the thing and I just, release the handle. I go back to my hammer, right? So it means that I'm throwing this thing and I don't know where it's going. So that would be stupid because I don't know if it's a boomerang and if it can come back to me, So even if I'm the stupidest guy in the world, I'm not sure that I want to do that because it's random. But that said, so that's why I always believe that somewhere, somehow, I was talking about the string of commands, there is somebody in the loop that make a decision. And this decision is to, decide what is the level of autonomy that you give to this thing. Of course, there are a lot of things that are autonomous, really, I mean, most of the time at the end. And I'm not going to make a course of what is happening with the drones, for instance, you know, how they detect their targets and stuff. But it's obvious that at the end, I mean, it's not me, you know, driving the drone anymore or driving the bomb or the missile anymore. It's the missile itself that goes to whatever we told them to, you know, target. So I don't believe that fully autonomous exists. Mm-hmm. You know, there is always somewhere a human that decides something. And if they were fully autonomous something, it would be stupid because it can come back to me and kill me.
You said earlier that tools and AI can be hacked, and so can human brains. I do agree on that. A question of Jens Anders. He asked, considering that there were already problems of fake information generated with AI on the internet, considering authenticity of information, what are the most important aspects to ensure trustworthiness of the information in space applications, but not only?
Yeah, that's a very, very important thing to understand. You know, in terms of AIs, and in particular in the latest systems, you know, that are the statistical systems that I'm talking about. Statistical systems, they are based on data, right? And the data, as we just said, they are not always good, right? And especially if you are talking about those generic, the systems that want to be as generic as possible, they are, you know, using a lot of data that is not good. I mean, we all know that everything on the internet is not true, right? And a lot of those systems, they are using the internet, and then they are using the data that is generated by the AI itself, what we call the synthetic AI, the synthetic data, sorry, that is being fed back in the next generation of models. So it's actually going to be worse and worse. I mean, it's the truth. So today, and it depends on the question, it depends on a lot of things. I mean, it's very difficult to calculate the accuracy of those systems, to understand what is the good answer, the bad answer. It depends on the specialization of the database, it depends on a lot of things. But if you take, for instance, a ChatGPT, you know, a generic ChatGPT, I mean, today the error rate is about 40%. 40%. I mean, it's a lot of errors. Yes. So once you know that, this is where you're going to come back to the people who are using the AIs, and who are going to be the responsible of using that by maybe, you know, using their critical sense in order to decide what it is that I'm going to do with those tools. Am I going to use 2 of them maybe to have a second opinion? This is what we are doing with medical, you know, resources and stuff. Am I going to have, you know, a third opinion? Yeah, it will be good. You know, the more opinions I have, maybe it's good. Maybe it's overwhelming. Maybe, you know, I need to have a synthetic view of that. So anyway, the bottom line is that I need to be educated, you know, on the different ways I can use those AIs, the way they were built, the way they are working, in order to be able to choose them correctly. But at the end of the day, especially when I am a specialist of the area in which I'm going to use the tool, I mean, I'm the specialist. So I know stuff. So I should use this AI or this tool as, you know, a help. I like to call AI, you know, augmented intelligence. This is going to augment me in some cases, but I'm going to augment it in some cases. It's a joint, you know, work that we have to do. In special cases, again, I mean, we cannot generalize, you know, what I'm saying for every single domains, but be sure to use the tool in a critical way, in a critical sense way, when you are going to be the decisive portion of the full, you know, path.
Mm. And perhaps one last question, that was the first one that was being raised, from Pierre Codis. With the massive adoption of agentic AI in all vertical applications, do you see the adoption of PKI and 509 certificates to systematically authenticate these agents like it is done at scale today with workloads, containers, microservices?
So, I mean, the good thing about the agentic AI, first of all, if we need to explain what is the good part of it. The good part of it is that every single agent, so the in the agentic system, you have a bunch of agents, and every single of the agents, they are much smaller, first of all, and much smaller means much more specialized in one specific area. And what you are going to do, we are going to put together all those agents in order to orchestrate them to do some very complex tasks, right? But every single of them, they are going to be better in terms of performance and in terms of accuracy and all those things that we talked about before than one that will be more generic, right? So they are going to be very good. And now you are going to be able to certify every single of them much better because they are very specialized in one area. So all the certificates that you could get, you can get that for every single piece of the system. And then the orchestration is going to be the meat of the system in the sense that this is going to be the complexity of the system. This is where it's much more complicated, but this is where you can also, this is the beauty of those agent systems that are basically not coming just from the agentic AI that is pretty new, but the agents are back, are done back in the 80s. In the 80s, we are doing also already, the orchestration of agents. And the systems that are doing these orchestrations, they are the ones that are going to be able to make the decisions of calling agents in parallel or doing some decisions about who is doing the best result and choosing the result to go to the next steps and so on. So this part is the most difficult part, and it's much more difficult to put a stamp on it, to say that this is something that we can certify. But at the same time, this is the meat of the system in the sense that this is where the intelligence is going to reside. So I would say that this is where the specialty and the area, the domain in which you are going to be good at is going to be your differentiator with the potential competition, because you are going to be able to have the best way to do this orchestration. And then, you are certifying yourself, basically, on the quality of what you can deliver.
Thank you very much, Mr. Julia. It is already, time out. We went a bit further, but I couldn't stop. Thank you so much. It was a very stimulating way to start the day. It was as much a talk on AI than that of general philosophy. What is intelligence? What is our purpose? What responsibility do we hold in what we do and what we decide? Thank you very much. A warm round of applause.